Hello guys, welcome back to the channel. Hope you guys are doing extremely well. Today we will today we will going to solve the problem walls coloring, which is the POTD of 14 February 2023 of GFG. What the problem states is, let's understand. The problem says that there are n rows. There is a row of n walls in Geeksland. Means there is a row and which contain n walls, and the king of Geeksland ordered Alexa to color all the walls on the occasion of the New Year. So in the Geeksland, it is uh, it is a New Year occasion. So the king of the Geeksland wants that all the walls of the Geeksland should be colored. Alexa can color each wall with either pink, black, or yellow. So Alexa has three colors: pink, black, or yellow, and the cost associated with coloring each wall with a particular color is represented by a 2D array of colors of size n into 3, where color size 0 and color size 1 and color size 2 is the cost of painting the ith wall with colors pink, black, and yellow respectively. And we have to output the minimum cost to color all the walls so that no two adjacent walls have the same color. So let's understand what the question is saying. Question has given a n into 3 matrix which which represent the cost of coloring a wall with a particular color. For example, here n equal to 3 means there are three walls: wall number 1, wall number 2, and wall number 3. So the cost of coloring first wall with the pink color is 14. The cost of coloring first wall with the black color is 2. The cost of coloring first wall with color yellow is 11. What this row is signifies, and this and this is the same for the second wall. Means the cost of coloring the second wall with pink color is 11 and with black color is 14, and the cost of coloring second wall with yellow color is 5, and so for wall number 3 we have the three colors, so three cost. So that is given here. The cost of coloring each wall with a particular color is represented by a 2D array of size n into 3. Okay, so what we have to output, we have to color the walls such that no two adjacent walls have the same color. Means the adjacent walls should have the different color. So like that, if first wall is pink, then second wall it can't be pink, it can be either black or yellow. Or if first wall is black, then the second wall can't be black, can't be yellow, it can be either pink or black. And if the first wall is yellow, then the second wall cannot be yellow, it can be pink or black, and so on and so forth for all the walls. Like if the second wall is black, then the third and first wall can't be pink. Then the first and second wall can't be pink, and they can either be black or yellow. Means the two adjacent walls can't have the same color. So we have to output the minimum cost because it is the cost array. So for example, so what is the minimum cost in this array? For the first example, here we can paint the first wall with black color, which will give the cost 2, and the second wall with the yellow color, which will give cost 5, and the third wall with black black color, which will give the cost 10. These first and third wall is not adjacent. Okay, first and second is adjacent, second is adjacent with first and third, and the third is adjacent with 2. So first and third wall can have same color. Okay, so here the output is 10 because we will color first wall with black, second wall with yellow, and this. And for and the example in second test case is 1 2 3. So here we will paint the if we paint first wall with pink color, then what are the choices for the second wall? It is either black or yellow. So if we color the first wall with pink color, then we can't have the pink color for the second wall. So we have to choose either 4 or 6, and that will increase our cost. So what we will do, we will color the first wall with black color with the cost of 2. We have pink color with less cost, but we will not paint it because it will overall increase the cost. So we will paint the first wall with black, and then the second wall with pink color, and the total cost will be 3, which is the minimum possible. Okay, it is a standard question of dynamic programming. As you can see, the topic tags are dynamic programming only. So what is the approach we can do? So whenever there comes dynamic programming, you should think of a recursive solution. Take what we will do in the recursion. For example, let's open the first test case. Let's open 1 minute. Should copy the test case. Okay, I should copy the test case. So for example here, so we will we will write a recursive function which will compute the answer for us. So what we will do in the recursion, first we will paint first wall with pink color, and then what are the choices for remaining walls. मतलब what are the choices remaining for the second wall? It is either, if I had painted this with pink color, then the choices remaining for this is 14 and 5. Okay, so let's draw the recursion tree here. If if I have chosen, first wall with 14, then what are the choices for this wall? Second wall we have choices for 14 and 5. We can't paint this wall with pink, 11. So if we will have second wall 14, then what are the choices for third wall choices are again 14 and 10. Okay, I am just writing the cost here. So we can either pick 14 or either pick 10. So what we will optimally pick, because it is the last wall, we will pick the minimum of among all possible. So it here is 14 and here is 10, so we will pick 10. So up to second wall, what is the answer here? It is 24. Okay, if we are painting first wall with pink color, and what are the remaining choices for second wall? Second wall remaining choices are 40. We can either paint with black color which cost 14 or 5. If we will paint 5, then what are the remaining choices for the third wall? It will be 14 and 3. 14 and 3. So what are the minimum of these? Minimum of this is 3. So it will be returned here. Sorry. It will be returned here. 3 will be returned. And here the total cost will be, if 3 is returned here, the total cost will be 8. Okay, up to the second wall. If I paint it with second wall with black color, then the cost till second wall will be 24, and if I paint with yellow color, the cost will be 8. So what is the minimum among these? Minimum among these is 8. So we will return 8 from here. Okay, so we will return 8 from here. So it is 8. 8 is what? If we paint the first wall with pink color. What are the remaining choices for first wall? If we paint first wall with second color, means black, what are the remaining choice for second? It will be 11 and 5. 11 and 5. Okay, and if I paint this with 11, then what are the remaining choices? 3 and 10. 3 and 10. So what is optimal here? 3 and 10. What is optimal here? We will always choose 3 because it is the minimum possible. If we are on the last, then here will be 14. 14, and if we will paint with 5, then what are the remaining choices? It is 14 and 3. 14 and 3. So here will be 8 total, and up to the second wall we have 14 and 8. What is the minimum among these? Is 8. Okay, so 1 minute. It should be like this. It should be like this. Here is the this and second. So the minimum cost will be 8 if we will paint. 1 minute. I am okay. Okay. So if I have missed it that up to here it is 24 and 8 minimum. And what is the cost of painting till the first wall? Means all the walls should be painted. So it will be added. So what is 14 plus 8? 14 plus 8 is 22. So it will give 22 as the, and here we have 8 and till this is 2, so it will give 10, and one more recursive call is left. Means here it, you can think it is of a parent. 14, I have choice for 14, then 2, and now choice is left for 11. 11 is left, so now we have two choices for second wall, which is 14 and 5. 14 and 5. And if we have chosen 14, then what are the remaining choices? What are the remaining choices? Remaining choices are 14 or 10. Again 14 for the second and 10. And here 5 remaining choices are 14 and 3. So minimum is 3. So here will be 3 returned, and up to 5 plus 3 is 8. So 8 is here, and 8 plus 11. Okay, and we will have from this 10. 10 and 10 plus 14 is 24. 24. Okay. So what is the minimum among these? 8 and 24? 8. So 8 will be returned, and 8 plus 11 is 19. So what is the minimum among these three? Means 22 and 10 and 19. It is 10, so minimum will be returned, and this will be the answer. So 10 will be the answer. 10 will be the answer. So you should have thought the recursive solution, then we can memorize it to find the answer. So let's see the code for it. So let's see the code. So what I have done, first we will only see the recursive solution. I have implemented the memoization technique here, so we will understand later. So I am going from back to front, means I am painting first with first the last wall, then second last, then going towards first wall. Okay. So what I have done here. Okay. So in this problem, we have to, means if I have painted this first wall. Okay. So I have to I have to place a restriction on this first wall. I have placed the restriction on this first color for the second wall. Okay, so this we will do with the help of a variable called chosen. Okay, so so how the code starts? Let's see that. So first I have called the recursive function. I have find nonce function, which will pass colors and n minus 1, which is our last wall, and minus 1, because minus 1 for that we have not painted a single wall yet. So if we have not painted any wall, then we have three options available. Okay, so what we will do here, now let's see from here. If chosen is minus 1, means we have not painted any wall. So I have made three variables, pink, black and yellow. Pink signifies that if I painted this wall with pink color, then what is the best answer possible if I paint this with pink color. Okay, so what we will do, in pink variable we will store colors of n plus 0 plus I will, for example, like this, I will, if I want to paint this wall with pink color, I will, 14 will be added to our answer. So that's colors of n comma 0, and 0 is signify the pink index. Okay, and I will call a recursive function finance for n minus 1, means from here to call the, to compute the remaining minimum answer if I painted this for this. So for the black color, so we will add colors of n plus 1 and call the recursive function to call the remaining, to paint the remaining wall with the minimum color, and so on and so forth. And after these three are computed, we will return the minimum of pink, minimum of black and yellow. As you can see here, when all these are computed 22, 10 and 19, we have returned the minimum answer. Okay. So if chosen was not -1 means I have, if okay, here you can see, if I have chosen the pink color means I have painted it with pink color, then I have passed 0 in the chosen variable, means I have chosen the first color means of pink color. If I have chosen the black color, then I have passed 1 here, and if I have chosen the yellow color, then 2 here. So what is, if chosen is 0 means you can think it like that, its previous wall or adjacent wall that is just painted is of pink color. If it is of pink color, we can't choose pink. We have the option either black or yellow. So here you can see we can't paint pink, so we can paint either black or yellow. So if we can paint either black or yellow, so what contribute to our answer is n and 1, and we will call the recursive function as it is and pass the 1 because now I have painted it with black color. So for this adjacent wall, when the recursive function will go, it will tell that its adjacent wall or its, you can say its parent wall is painted with black color. So you can't choose black color. And so we will return main of black and yellow. So if chosen is 1, then you can say that we have restriction on the black color, and if chosen is else, the value of chosen can be 2, so we have restriction on yellow color. So if we have to restriction on black color, then we have option pink and yellow, and if yellow is restricted, then pink and black, and we will return the minimum of these. So what is the base case here? When we will reach the last wall available means if n equal 0, if n equal 0, we will reach here. So what was the base case? As you can see that when there are, when we reach the last condition, we will return the minimum of all possible answers among what we will return the minimum among the what we can choose. So we will return the minimum of, if n is 0, then we will see that if chosen is -1, that it can be that condition that if there is only a single wall, then directly will n will be 0. So we will return the minimum of all three colors, minimum of n0, n1 and 2. If chosen is 0 means its adjacent wall, means if I am on this wall, then this then its adjacent wall must be pink. Then what we have the options available, we have options well black or yellow, so we will return minimum of black and yellow. If chosen is 1, we will return minimum of 0 and 2, and if this, we will return minimum of n is 0. It is the recursive solution. So we have only to memorize this and it will become the DP solution, and when and it will pass the constraints. So what are, so in the DP you must know the states. What are the various states available? So as you can see here in the recursive function, as you can see in any recursive function, there are only two variables changing. First is n, we are decrementing n by 1, and second is chosen variable. Okay, so you can think that we will need a 2D vector, but of what size? First is n size because it is going from n until 0. It is going from n till 0. And okay, so these are the rows. And what is the column size means what? So as you can see here, the chosen variable has only three options, 0, 1 and 2. So we can make a 2D vector of n into 3 size, n into 3 size. So it will signify a row, and these signifies the column, means it is 0 and 1 and 2. If I have painted with black color, then it is here. If I painted with pink color, then here. Then if I painted with yellow, then here, and so on. Okay, So what we will do, we will make a vector of int of n size and vector of int of 3 size, and we fill all with -1. As you should, as you know that what we will do in memoization solution, if chosen and not equal to -1, because if it is -1 then we have just started, and so, and the vector can't have -1 index. So if it is not -1, then, and if dp of n comma chosen means if I have chosen the first wall and I am the nth index, if it is painted, then means it is not -1. So we will, so we have computed the answer in the past, obviously. So we will return directly dp of n comma chosen directly, and when we are computing the answer, means if chosen is 0, then we will directly put it in the dp vector, dp of n comma chosen this and dp of n comma chosen this. And so here is the memoization solution with recursive approach. So we will just submit it, and you can see passes all the test case. Okay, thank you guys, bye bye, and hope see you in the next video. And if you guys have any doubt, you can post it in the comment section. Thank you, bye bye, take care.